Hello everyone. Today we will be discussing various aspects related to the topic of quality costs. The following will be our topics of discussion in this video. Firstly, we will be looking at the different types of quality costs that are associated with the production of a particular product. Secondly, we will be looking at various methods for measuring them. And finally, we would be looking at the impact of quality improvement techniques on them. Firstly, we will understand the meaning of quality costs. Quality costs reflect the achievement or non-achievement of meeting product or service requirements as determined from the perspective of the customer. Now, the last phrase of this definition, the perspective of the customer, is very important because until and unless they deem it to be acceptable, all the efforts of the company will have been in vain. These requirements may include design specifications, operating conditions, government regulations, timely delivery, marketing procedures, among various others. The quality costs can be broadly divided into two categories: the costs of conformance and those of non-conformance. The costs of conformance include the cost of those efforts which would have been put into the production of the product so that it achieves the requirements as specified by the customer. The prevention costs are included in this, whereas the costs of non-conformance would be if the product is not up to the mark as specified by the customer, then various efforts would have been put in by the company so as to remedy the situation. Those would be the costs of non-conformance. Appraisal costs and failure costs would be included in this. We will discuss all of the costs in detail in future slides. What are prevention costs? Prevention costs are incurred in planning, implementing, and maintaining a quality system to prevent poor quality in products and services. Following are some of the examples of prevention costs for your reference. These increase with the introduction of a quality system and initially may be a significant portion of the total quality costs. However, the rate of increase slows with time. Even though prevention costs increase, they are more than justified by the reductions in total quality costs due to the reductions in internal and external failure costs. Now, the last 2 points discussed may seem a little muddy right now, but I'm sure as the discussion moves forward, they will be clear to you. Now, we will look at the various costs of non-conformance, the first of which is an appraisal cost. Now, appraisal costs are those associated with measuring, evaluating, or auditing products, components, purchased materials, or services to determine their degree of conformance to the specified standards. Following are some of the examples of appraisal costs. Now, appraisal costs typically occur during or after the production, but before the product is released to the customer. So, they are associated with managing the outcome, whereas the prevention costs are associated with managing the intent or the goal. These normally decline with time as more and more non-conformities are prevented from ever happening in the first place. Now we will look at the second cost of non-conformance, which are failure costs, which are further subdivided into two. The first of which is an internal failure cost. Now these occur when the products, components, materials and services fail to meet the quality requirements prior to the transfer of ownership to the customers. Now these would naturally disappear if there were no non-conformities in the products and services. Following are some of the examples of internal failure costs. Now, as a total quality system is implemented and becomes effective with time, these would decline. Less scrap and rework will result as the problems are prevented from happening in the first place. Now, we will look at the second failure cost, which is the external failure cost. Now, these are incurred when a product does not perform satisfactorily after ownership is transferred to the customer or services offered are non-conforming. If no non-conforming units were produced, this cost would vanish. Following us some of the examples of external failure costs. A reduction in external failure cost occurs when a quality system is implemented successfully. Now we will discuss a category of quality cost that is slightly different from those discussed until now, that is the hidden failure cost. Scrap, rework or warranty are measurable components of failure costs which can be easily tracked by the accounting systems. But a significant segment of the failure costs are hidden. Look at these examples. After reading them, you will realize that they cannot be easily tracked or quantified by the accounting system. Hence, what is typically reported as failure costs is but a minute portion of the true failure costs. It is like the tip of an iceberg. Now, we will understand the reason for setting up meticulous accounting procedures as well as data collection procedures for the quality cost data. These costs should be monitored carefully because indirect costs are as important as direct costs of raw material and labor. Well-defined accounting procedures should be set up to determine realistic quality cost estimates. Consider the case when quality cost data has to cross departmental lines in a company. This occurs, for example, when a quality control supervisor in a staff position identifies a reason for scrap or rework in a product, and a machine operator conducts an extra operation to rework those items. Or consider another scenario where a rework or scrap done on a product would inspire a change in the product design. So in the first case, the work done, the time spent in the rework, and in the second case, the time spent for the redesign will be assigned to quality costs. The figure shows the data requirements at various management levels. Data are collected for each product line or project and distributed to each level of management. The needs are somewhat different at each level. The top management may prefer a summary of the total costs broken down into each of the four categories at the division or plant level. On the other hand, line management or supervisors may want a summary of the direct costs, which include labor and material costs, as it relates to their area. Thus, a cost-wise breakdown into the four categories of prevention, appraisal, internal failure, and external failure is incorporated into the accounting system for the variety of functions performed by the management and operators. Information from cost systems must be used to identify the root causes associated with failures. Only when remedial actions are taken to prevent these from occurring will the true benefits of a cost system be reaped. Now we will look at the various methods of measurement as well as interpretation of quality costs. The magnitude of quality costs is important to management because indices such as return on investment are calculated from it. However, for comparing quality costs over time, or magnitude may not be the measure to use because conditions often change from one quarter to the next. The number of units produced may change, which affects the direct costs of labor and materials, so the total cost in dollars may not be comparable. To alleviate the situation, a measurement base that accounts for labor hours, manufacturing costs, sales dollars, or units produced could be used to produce an index. These ideas are discussed in detail in the following slides. One commonly used index is the quality cost per direct labor hour. The information required to compute this index is readily available since the accounting department collects the direct labor data. This index should be used for short periods because over extended periods the impact of automation on direct labor hours may be significant. Another index lists quality costs per direct labor dollar. So here instead of the number of hours that a laborer has put in, the amount of money that has been paid to the labor would be considered. Now it is safe to assume that even if it increases over time, because of inflation in all the aspects, the quality cost would also increase, which would lead to a stabler value of labor wage index. This index may be most useful for the line and middle management. Now let us look at the cost-based index. This index is based on calculating the quality costs per dollar of the manufacturing costs. Direct labor, material, and overhead costs make up the manufacturing costs, and the relevant information is readily available from accounting. This index is more stable than the labor-based index because it is not significantly affected by price fluctuations or changes in level of automation. For middle management, this index might be of importance. For top management, quality costs per sales dollar may be an attractive index. It is also known as the sales-based index. It is not a good measure for short-term analysis, but for strategic decisions, top management focuses on the long-term outlook. Sales may lag production and may be subject to seasonal variations, like during Christmas there may be increase in the sales of toys. These variations have an impact in the short run, but they smoothen out over longer periods of time. Furthermore, changes in selling price also affect this index. Now we will look at the last index, which is the unit-based index. This index calculates the quality costs per unit of production. If the output of different production lines is similar, this index is valid. Otherwise, if a company produces a variety of products, the product lines would have to be weighted and a standardized product measure computed. For an organization that produces refrigerators, washers, and dryers, it may be difficult to calculate the weight based on a standard product. For example, if the washer is a standard unit, is the refrigerator 1.5 and the dryer 0.9 standard units, these values may differ from person to person. So, in such cases, other indexes should be considered.
As discussed earlier, various indexes to measure quality cost. Now we will discuss something new. Suppose you are owning a manufacturing industry. You want to earn a good amount of profit and also provide a quality product to your customers. Now, increasing the quality of your product too high would lead to higher manufacturing cost, which would lead to less profit, and giving a poor quality of product is not acceptable. So, there is a need in the industry to determine optimum level of quality. Let us study that. The main aim to determine optimum level of quality is based on minimizing the total quality cost. There are basically two approaches: traditional or static approach and dynamic approach. Static approach. It does not incorporate the impact of quality improvement, which is the main fiber of any industry. See this graph. Actually, increasing the level of quality would lead to prevention and appraisal costs to increase at an exponential rate. And on the contrary side, internal and external failure cost decreases with improvement in quality. You can see these curves. This is the curve of prevention and appraisal cost, and this is the curve of internal and external failure cost. The total quality cost function is the sum of all these quality cost prevention cost, appraisal cost, internal and external failure cost. So this is the curve of total quality cost function, and as discussed earlier, optimum level of quality is based on minimizing the total quality cost function. So this is the lowest total quality cost function. Let's take its x coordinate, which is the level of quantity, which is q naught. This is the optimum level of quality. Now, let us discuss dynamic approach. Here we have to take into consideration the concept of continuous quality improvement. This is a far more appropriate process for analyzing the quality cost and the manner in which it is affected by continuous quality improvement. Firstly, with continuous improvement, there is not only a reduction in unit cost of the product, but also change in the shape of prevention and appraisal cost function. Usually, the rate of increase of this function with the level of quantity will be smaller than in the original situation. Now, see this graph. This is the new curve of prevention and appraisal cost, which has shifted towards down and slightly towards right. But the internal and external failure cost function remains the same. Therefore, this is the older curve of total quality cost function, and as total quality cost function is the function of all these four parameters, the new quality cost function has also shifted slightly downwards and towards right. And to determine optimum level of quality based on minimizing the total quality cost function taking its x coordinate, which is q2. Now we can see this from this graph that the desired level of quality has increased from q1 to q2. Also, there is a reduction in the quality cost. Therefore, this approach is far more used in the industry and it is far more realistic. Now, what are the effects of continuous quality improvement? Improving in the quality leads to improved customer satisfaction. Also, the market share of the company increases. This would indirectly mean that the manufacturer can charge higher unit price of the product. Now consider you are an industry and you are maximum profit, and we can assume that profitability function is the product of market share and the difference between unit price and unit cost of the product. As already discussed, the market share would increase, higher unit price, and in the first slide we have discussed unit cost of the product also decreases, which means that the profitability function increases from all the three angles, which is a win-win situation. Thank you. This is it for my side.